This is the Unit 7 and 8 portion of the Semester 2 study guide. Taking a look at this first problem, what's things that you need to remember is that when you have the center angle to trace, stretch, and sweep any diameters, and of course they add up to 180. Also keep in mind that measure of a central angle to its arc the same. And short arcs, minor arcs, less than 180 have 2 letters. Major arcs have 3, so the fact that this has 3 letters, you go in that exact order and it's bigger than 180. So F, G, D would be right there. Obviously you solve for X, and then you find that arc. You're given the circumference, you need the area, and remember apple pie is really, really good. And you're starting with circumference, so it's C, d pi, I C d pi. So if d pi equals 20 pi, you take it from there, you solve for the diameter, solve for the radius, solve for the area. Length of an arc, length of an arc. Now, the length of this arc is not 210. The measure of that arc, measure of the arc is that central angle. So the measure is 210 degrees, but the length of the arc is a fraction of the circumference. How do you find that fraction? It's theta over 360 times circumference d pi. That is arc length, fraction of circumference. When you go to solve that diameter, pi is in the top, and then you reduce. Sector area is a fraction of the area. So a sector is that theta over 360 times pi r squared, because it's a fraction of the area. Things you need to watch out here for inscribed angles, a couple of them. Anything that's on, any angle that's on, its angle equals whatever the arc it's grabbing over 2. That's an inscribed angle. Anything that's the on angle. Also over here, when you have an inscribed quad, keep in mind that opposite angles of an inscribed quad, let me just give you an example here. Let me color code it. So that blue angle would grab this way. Let me change the color here. That green angle grabs this way. It's an inscribed quad. And notice we're grabbing a full 360. So that means these two angles together must add up to 180. So the opposite angles in an inscribed quad add up to 180. Once again, keep in mind, any on angle is whatever the arc is over 2. So for here, you would take this arc and you would double it. And then watch out for really simple things like the fact that circles add up to 360 degrees. For these two, The trick you need to remember is any line that's tangent. Tangent means to touch at one point, a straight line, to a radius. There's going to be a right angle at the edge. If tangent to a radius, radius, radius. If tangent to a radius, radius, radius. Tangent to a radius, right angle at the edge. You also need to know if you have two tangent lines, which we do here, that they are going to be congruent to each other. So in this case, two equal sides, two equal angles. Over here, your tangent line would be this way, tangent to a radius right angle at the edge. Also, one thing to watch out for is all radii are congruent. So radii create an isosceles triangle always. Two equal sides, two equal angles. Sketching a circle graph. That equation is x minus h squared, y minus k squared equals radius squared. So you ask yourself, what would the h be here? That x is by itself, and in this case, h would be 0. What would the k be? Notice the flip of the sign. That means the k had to be -1. And if r squared is 4, the radius squared is 4 square root. That means the radius is 2, and then you graph x minus h parentheses squared, y minus k parentheses squared equals radius squared. That is the equation of a circle. You can use that equation down here to actually write x minus h squared, y minus k squared equals radius squared. The only thing you need for an equation of a circle is the center coordinate and the radius. So when you look at your given information, ask yourself, what piece of that information am I still missing? These are nets. The most important thing you could do with a net is to pretend you're holding that physical flat shape in your hand and go through the process of folding it together mentally. If you were to take this and fold it, there'd be triangles that you would fold all the way around. So you ask yourself, would this have one base or two? If it has one base, it's pyramid. If it has two bases, it's a prism. This only has one base, which means it is a pyramid. So you have to be able to kind of draw a slightly squishy, because you have to do 3D and it's 6 sides. And these edges are all 11 all the way around. And the apothem here is 9.5. And those are going to come to a point and create triangles and create a pyramid. Find the volume of each figure. So remember when you do this that the bases for a prism, they are parallel. They are congruent, parallel, and connected by rectangles. And if it's a prism with two bases, like this one, we know volume's going to equal area of one base times the height. And then you have to go through the process of asking yourself, what is the shape of the base? Because that could change. In this case, the shape of the base is a regular polygon. So our base, capital B, is perimeter times apothem over 2. For a pyramid and a cone, its volume equals base times height over 3. Once again, you need to go through the process and define what is the base. The base here is a right triangle. So I'm going to circle the base and come over here, and that's leg times the other leg over 2. That's going to constitute our base times our height, which we already have, over 3. So prisms are base times height. Pyramids are base times height over 3. And then spheres, if we're doing volume, 4 pi r cubed over 3. It says right here, we have information about the surface area and volume of similar solids. Once you establish something is similar, when you change dimensions, you change ratios. This is where you have to do your x to the first, y to the first, x to the second, y to the second, x to the third, y to the third ratios. You have to do all 3 in order to establish your ratios to solve. So taking a look at number 9, we are given the surface area. So right off the bat, you have a 1D, 2D, 3D ratio. And if we're in surface area, we're going to be starting in the second dimension. So I take the time and to get the ratio, we don't use the actual surface areas, we want the ratio. So we need to take 392 and 8, and we are going to divide them both by the same thing until you can't get anything else. So I'm going to divide, because they're even, I'm going to just divide both of them by 2. I know this is 4. 392 divided by 2. Try to avoid using a calculator. It's good for the brain. Get some exercise here. 2 goes into 3 once. 2 goes into 19 9 times. And then 2 goes into 12 6 times. And I still have 2 even numbers, 196 and 4. So I'm going to divide them by 2 again. That's 2. And we get 196 divided by 2. 2 goes into 19. That's going to be 9 times. That's 18. And 2 goes into 16 8 times. So I have 98 to 2. I'm going to divide by 2 one more time because they're both still even. And I get 1 and 49. And once you can't divide any more evenly by the same number, you know you're done. So I'm in the second dimension here, and I'm at 49 to 1. So I'm in the x squared position. So I backtrack. Square root of 49 is 7. The square root of 1 is 1. Then I come forward, and I do 7 times 7 times 7, which is the cube. This is going to be 49 times times 7. That's 343 to 1. Now you take a look and see what ratio you actually have. We want the volume here, so we're going to use the volume equation. So volume, I'm working left to right, 343 to 1. That's left to right equals 8918 to unknown, left to right. On the right-hand side, you take a look here and you see what we're working with here. Here you're starting in volume. So right off the bat, we know we're starting in the third dimension. So we have 1D, 2D, and 3D. So we are starting in the third dimension. So once again, you just start dividing by the same number. 405, 960. Both of those are divisible by 5. So I'm just going to take a 5 into both. I have 81 and 192. I think of numbers that go into 81, and 8 plus 1 is 9. 9 is divisible by 3, so I know that's divisible by 3. 1 plus 9 is 10, plus 2 is 12. That's also divisible by 3, so I know both of these are divisible by 3. Three goes into 8 twice. I get 27. 3 goes into 19 six times. 64. So I have 27 to 64, and that's not divisible anymore by the same number. And that means 27 to 64. Now I have to find what number times itself is 27 3 times. What number times itself is 64? That's why it's good to memorize your cubes at least 1 through 10. Because if you do 3 times 3 times 3, 9 times 3, 27, check. 4 times 4 times 4, 16 times 4, 64, check. So your ratio here is 3 to 4. You square it, 9 to 16. And you are using, because it's surface area, you would use the 9 to 16 ratio.